There was an explanation of matrices posted in the Houdini for Max's group, and I thought it was maybe a bit more complicated than it needed to be. So I'm going to run through a quick visual guide as to how it works instead. This video isn't intended for everyone doing 3D. Matrices are kind of generally used in things like character rigging and kind of particle and effects work. So if you're not on the technical side of 3D animation, you might never find a use for this information whatsoever. But if you know what a matrix is, or you've heard of them before, then hopefully this will be a bit useful for you. First of all, what actually is a matrix? A matrix in a 3D program is how the program stores the transform information for any of the objects within the scene. So they're going to contain the position, rotation, and the scale information for each of the objects within our 3D scenes. So let's have a look at what one of those actually looks like. I'm using 3ds Max for this, but matrices are the exact same in every other program as well. So you might have to find some different buttons or script commands to be able to look at them, but the knowledge works the exact same way in all the rest of the programs. So I'm just going to I'll make a quick object here, just make a teapot, and okay, just in the script editor in Max, I'm going to get it to show me the transform of this object here. So the transform command in 3ds Max will show you a matrix. Okay, so this is what a matrix value looks like when it's written in text. So you kind of have 4 different entries within it. So what I'm going to do is I'm actually going to start from the 4th one here because it's really easy. So we're just going to go through that and then throw that out straight away. So the very last set of numbers here. Each of these sets of 3 numbers, by the way, is just kind of like a coordinate or a position value. Like it's a position in 3D space, and I'm going to explain how that gets used later on. This last one here, though, which is currently 0, 0, 0, is the actual position of the object within the 3D scene. So the last value in a matrix is the actual position of the object itself. It's really simple. There's nothing else complicated about it. It's literally only that. So if I move this object, I'm going to move it to 10, 20, and 30. Zoom out so I can see it. Okay, we're over there. I'm going to clear that, and I'm going to ask for this transform value again. And you can see that that last thing is now changed to 10, 20, 30, which is the same as my coordinates here. If we do something smaller, let's do 1, 2, 3, just so it gets a bit closer again. I'm going to clear this, get the transform again, and you can see again this has gone to 1, 2, 3. So this value at the end here is literally just the position of the actual object. So it's kind of where the pivot point of your object is in your 3D scene. So that one's nice and simple. So we can never forget about this 4th value here and just concentrate on the first 3 instead. So let's delete that. Okay, so the other 3 values. So what the 1st, 2nd, and 3rd values in a matrix represent are the x, y, and z information for the object. And sorry, what I mean by that is it's the x, y, and z kind of direction or rotation values for the object. It's also going to be the scale values too, and we're going to look at the scale as the last thing. But each of these things has got to do with kind of like the x, y, and z alignment to the actual object itself. So if I'm just going to make a teapot again because it's kind of handy. Yeah, okay. If I go into move mode, you can kind of see that each of the 3 axes of the object is kind of pointing in a certain direction. So each of these 3 different values here within a matrix is information about each of these 3 individual axes. So they're nothing but like direction entries for which way each of the axes of your object is pointing. So it's kind of like where the rotation or the alignment of the object is stored. A direction within 3D software is normally called a vector. A vector is kind of like an arrow pointing in a certain direction, kind of like what we have in our transform handles here. You get the same type of thing in pretty much all the other 3D programs. Vector is kind of just a snotty word for a line. You kind of get that in mathematics an awful lot as well. So it's really only a word for a line. So I'm going to pop into Paint for a second. So a line kind of starts at one point and ends at another point. So if we have start point here, end point here, then a vector or a line between these 2 points starts here and goes this way. Sorry for my shitty drawing. So that's kind of all it is, really. A way that they kind of describe a vector is they kind of normally give you coordinates for the actual vector itself. Normally they start at 0, 0, 0, or the center of the scene, and they end at a different coordinate. They kind of end at a different point. So say, for example, if we have a vector with coordinates 5, 5 in here, that'll be kind of roughly up around there. What that means is our vector or our line, it starts at 0, 0, and it goes all the way up to 5, 5. So that's that one there. If we had one that's at like, I don't know, 4, 2 or something like that, that could be, or 2, 4 I should say. Let's say 2 is about there and 4 is about here-ish. So a vector 2, 4 would be starting at 0 and going all the way over to that. Very exciting. So it's the exact same with vectors in 3D as well. The only difference about 3D is that we have a third number at the back of this for our Z value as well. Okay, so let's pop back into 3ds Max. Now, okay, I'm going to delete this for a second. Okay, so let's make a quick example of a vector or a line or whatever we want to do. So I'm going to make a very exciting sphere, and I'm going to put it at 0, 1, 0. Let's make that kind of small, and I'm going to make this red. So this is at 1 on the x, 0 on the y, and 0 on the z-axis. And I'm going to make a little line between the two. So we'll pretend this line is our vector. So it's going to start at the center of the scene, and it's going to end at the center of that sphere. And I'm going to make that red. So that's like our vector traveling from 0, 0, 0 to 1, 0, 0, 0. Very exciting. Okay, so I'm going to copy that. I'm going to put that up on the y-axis as the next one. So another sphere here. Okay, so this one has now gone to, you can see the coordinates here. This is 0 on the x, it's 1 on the y, and it's 0 on the z. I'm going to make this one in green. I'm going to make these just to correspond with the colors inside in 3ds Max, just so we can see exactly what's happening with all of them. And same thing again, I'm going to make a line that runs from 0, 0, 0 to the center of this. There you go. Make that a brighter green. Okay, and I'm going to make a last sphere. And I'm going to put it at 0 on the x, 0 on the y, and then 1 on the z. And I'm going to make this one blue. Same thing again, just going to make another line, and the line is going to go from 0, 0, 0 in our scene, and it's going to end up at just 1 along the z-axis there. I'll make that one blue. Okay, so these 3 lines here could be considered vectors. They're starting at the center of the scene, and they're kind of like moving out and pointing towards each of our three spheres in a sense. Okay, so I'm going to make a teapot to go along with this lot here. I'll make that at the center of the scene as well. I'll make that too big. Now, okay, so, and what I'm going to do with our teapot is I'm just going to have a look at the matrix values for this teapot here. Okay, so now if we're to take a look at these three values here, again we know that this fourth value here is only the position of the object. Our teapot is sitting at 0, 0, 0 in the world, so we can ignore that. Let's have a look at this first value here. So this first value is supposed to represent the direction or the alignment of the x-axis of this object here. So you can kind of notice that, wait a minute, this kind of looks like the coordinates that we have for our red sphere down here. It's 1 across on the x, and then it's 0 on the y, 0 on the z. So if we were to look at the position of this sphere here, that's where the position of this sphere is here. Very exciting. If we were to select our teapot, and if we were to make our little transform handles bigger, you can kind of see that the direction axis of or the x-axis of our object is pointing at that coordinate 1, 0, 0, or it's pointing towards our little red sphere. If we were to have a look at the y-axis of our teapot, you can see that the y-axis, which again is this second number here, is 0, 1, 0. So what that is that's a vector kind of starting at the center of the scene, and it's pointing towards this coordinate 0, 1, 0. So if we have a look at our sphere that's at 0, 1, 0, you can see that the y-axis is pointing towards this sphere now as well. And then same thing is going to be is going to work with the z-axis as well. This is just a coordinate for another line that starts at 0, 0, 0, and it points towards 0, 0, 1, which is where our last blue sphere is here. That's at 0, 0, 1. And if we select our teapot again, you can see that the transform handle of the z, little blue one there, is pointing through that object. So you can see that the numbers for the x, y, and z data of the matrices kind of line up with these three different positions here, because that's pretty much what these three values actually are here. All it's kind of doing is it's just telling the 3D program what direction is my x-axis pointing towards, what direction is my y-axis pointing towards, and what direction is my z-axis pointing towards. It's not that much more complicated than that, and you can see that everything is kind of lining up nicely there. If I make little handles bigger, you can see that they just run through those coordinates here. So these are kind of like a simple set of numbers at the minute, and it's just because each of these little kind of like balls is only on kind of, it's only got values on one of these axes here. So right, I'm going to throw all this stuff out. Let's make some uglier numbers, and the handiest way to do this is if we make sure that the axis of our teapot aren't aligned nicely on the x, y, and z. So let's get it, and we'll just kind of randomly rotate this object to something a bit different. And okay, so we're going to do the same thing again. We're going to grab this object. We are going to get its matrix value. Okay, so you can see now that the numbers for everything has gotten an awful lot longer. They're much more complicated numbers, but they're the exact same thing as they were before. We're going to prove that in a second. So same thing as usual. We're going to ignore this last number here because that's only the position of the object. We don't really give a shit about that. And we're just going to take each of these three numbers individually. I'm just going to make a sphere for each of these three positions, and we're going to see whether the axis of our teapot lines up nicely with those. So let's make a little sphere. We'll make it red. Okay, so this is using these ugly numbers here, and all I'm going to do is I'm going to copy and paste those into the position of this object. So 0.8 there, 0.4 for my y, and then this for my z. Okay, and then let's make a green one. So second set of values. So for our green one, this is the x coordinate. This is our y. And this is going to be our z. Then another copy of that. And I'm going to make this one blue. And our last set of numbers here. Now, okay, so we've got these numbers here, and if we were to select our teapot, and what I'm going to do is I'm just going to change the coordinate system into the local coordinates of this object here, and there we go. Okay, if we make those handles a bit bigger just so that they stretch out and actually touch off each of the spheres, you can see that they align absolute unity perfectly with that. So each of these three numbers that we've got within our matrix value is literally just the direction each of the x, y, and z axis of that object are kind of pointing towards. So that's, okay, so that's kind of rotation taken care of. You literally just kind of look at these three values and kind of put them in, and you'll see that everything kind of points the correct way. Okay, so the last thing that we've got to look at is our scale. So again, you're kind of you look at the matrix values here, and you've got values for the x, y, and the z, and the position, but there doesn't seem to be any kind of scale values here. So we're going to look at one of the other properties that we have with vectors inside of 3D. So I'm going to delete all this for the minute. Okay. So the other thing that a vector has within 3D, it's we've seen that a vector has direction already by just the direction that it's pointing towards, and then the only other thing that a vector has is it's got a length. So we've seen our direction in each of those values there. So let's have a look at some of the length things instead. So if we're to make another sphere, okay, we're going to put this at, I'll go back into my normal world coordinates. I'm going to make that at 1 on the x. Okay, I'm going to make another one at 5, and then another one at 10. Okay, so if we had a vector going towards this first sphere here, let's just make a line again. So it's going to start at 0, and it's going to go towards 1. And the next one is going to, again, start at 0, 0, go towards 5. And the last one is going to start at 0, 0, 0, and go towards 10 on the x. So now, let's move each of these away from each other a bit so you can see them a bit better. I change the color as well. Okay, now, sorry, I missed that one. Okay, so again, we have 3 lines. They're all kind of pointing in the same direction. The only difference is if we were to pretend that this is a vector here, this would be a vector with a length value of 1 unit here, because you can see it's only kind of 1 square across in 3ds Max. The second one here goes 5 units across. And then the last one here goes 10 units across. So each of these, if each of these lines were vectors, they would have length values of 1, 5, and 10 respectively, just because you know, the distance that they travel is slightly longer in each case. So, okay, how does this actually apply to our kind of 3D bits and pieces in the first place? Okay, I'm going to go back to my teapot example for a second, just because, again, that's quite useful. Actually, no, sorry. I'm going to use a point helper inside in 3ds Max because it has options for the X, Y, and Z axis to be visible. So here's a simple point helper here, and hopefully you'll be able to see the X, Y, and Z axis on it. So I'm going to have a look at the matrix value for this. So again, I'll use my transform command. Okay, so same thing again. You know, we've got the same matrix values as we had before. The x-axis is pointing kind of towards 1 on the x, 0, 0. Y value, or the y-axis, is pointing towards 1 on the y-axis and 0, 0. And then the same thing with the z. It's just the exact same as it was before. Now, okay, what I'm going to do is I'm actually going to scale this object a little bit. So what I'm going to do is I'm going to go into scale mode in 3ds Max, and I'm going to make it twice as big on the x-axis only. Okay, so you can see that's now stretched out to double the length of the other 2 axes. So this is stretched on the x-axis only. So I'm going to grab that again, and what I'm going to do is I'm going to ask for its transform value again. Now, okay, if we compare these 2 things here, the only difference that you can see between the 2 is that now our matrix value that we have for our x-axis now just has a slightly bigger number than it had before, and conveniently enough, you can see that it's actually twice the value of the value that's above it. So this is actually kind of, this is how scale is actually stored within each of these matrix values here. All it does is it's got the same kind of direction as it had before, but it just uses kind of bigger values within it. And what we'll do is we'll do the same thing to the other 2 axes. We'll give them some scale values just so you can see what the numbers actually kind of look like within it. So I'm going to do 300 for this, and then 400 for the Z. And we'll just scroll out so you can see it. So same thing again, let's just take the transform values on that. So you can see now we've got, rather than going 2, 1, 1, where we only had scaling on the x-axis, now we've got 2, 3, 4, and you can see that that corresponds to the 200, 300, and 400 values that we have in our scale value inside there. So yeah, this is kind of how scale is stored within 3D programs. What it does is it just kind of makes the each of the axes of the matrix just kind of bigger in each direction, or smaller if you're scaling an object down. So you know, okay, these are very, very clean numbers here. They're easy to look at. So let's maybe kind of make a slightly kind of messier looking example, and we'll just see what those look like as well. So let's get a teapot again. No, actually we'll stick with our point because that's kind of clean. So if I was to rotate this randomly, just so that things aren't actually kind of aligned all that nicely. And okay, I'm going to go into the local axis of this again, and I'm going to scale. We'll do the same thing again, actually. We'll do 200, 300, 400. And let's look at our transform values that we have on this now. Ugh. Okay, so these are really messy numbers, and they're kind of getting bigger to look at. So same thing again. All we're going to do is we're going to completely and utterly ignore the position. What I'm doing here is I'm kind of leaving my object at 0, 0, 0, just because it's going to be much easier for me to kind of show where all these positions end up if the object is at the center of the scene. But again, this is just a position of the object, so we ignore that. So now, okay, if we were to take these coordinates here, we'll just make our usual sphere. So let's make a red one, and we're going to put this in for the position. Go there. I won't do this for all of them because you're going to get bored of looking at me doing this. You're going to get the idea, I'd say. Okay, so if we do that, I'm going to make this a little bit smaller. Now, okay, so it's the same thing. You know, if we were to take this as just a set of position coordinates and make a sphere, we can see that the axis of our little point helper just touches off the center of that, which is perfect, which is what we want. Now the only thing we want to do is we want to find out, okay, well, what's the scale value of this thing here? So we know by just selecting this object and going into scale mode, we can see that we've got like 200, 300, and 400 along there. So if we wanted to check that scaling in another way, we've got two options for this inside of 3ds Max anyway. Again, this is going to be program specific, so you might have to figure out a few bits yourself. One is that I've got another helper in 3ds Max just called tape, which will let me measure any distance. So what I'm going to do is I'm going to go from the center of this, and I'm going to measure to the center of this sphere here. Now, so my little tape measure helper here has a length value on it. So the length of this is going to be 2. So that's kind of equivalent of 200% scale in this case. If you've got something that's not scaled, it's kind of it's a length of 1 typically instead. So we'll delete that. I'll do the z-axis for this as well, just to kind of reinforce the point. Okay, so let's grab our z coordinates. Put that there. So now we scaled this object here 400% on the z. So again, if we were to take out our little tape measure object, and if we were to go from the center of our object out to where that little blue point is, you can see that we have a length of 4. So that's our 400% scale along that axis. There's kind of there's other there's other ways that you can get these values as well. Like if you're a technical artist, you're probably using kind of a bit of mathematics or scripting in the first place yourself already. So in 3ds Max we have a command that's just called length to be able to kind of give us the length of any kind of vector values. So if I was to type in the word length here, and if I was to give it this value here and hit return, so that gives me 2. So that's the equivalent of my object being scaled kind of like twice along its this axis here, which is our x-axis. Let's go back to scale mode just so we can see that again. If we were to do the length for this one here, that gives us 3, so that's our 300% scaling along that axis. And then same thing for this one here. That 3.9. Okay, so this is just like a maths error within the program. It's the program being kind of a bit crap in this sense, but that's, you know, that's 4 effectively, or 400% scaling along that side. So that's kind of that's the stuff behind it anyway. I'm going to put this back to normal, and I'm going to set its scale back to normal as well. And we'll clear all that. So that's it. So that's your matrix in that sense. You know, your fourth value there is position. Then you've got your x, y, and z axes, and these values here are nothing but position values. They're literally just kind of the position of the coordinates that the x, y, and z axis points towards. So they're pretty simple. They're simple positions within your actual 3D scene. If you want to, you can invent your own matrices as well. All you need to do is you just need to type in 3 different coordinates for the x, y, and z axis to point towards. If the coordinates that each of those axes are pointing towards are longer than a length of 1, it means you're going to get some sort of scaling within the object within the scene as well. But what I'll do is we'll leave that there. I'm going to make a third sphere here, and we'll just move these to like random positions, and we'll make a matrix out of that, just so you can see how you would create one yourself. So okay, let's put our x-axis somewhere there. My y-axis I'm going to put kind of here-ish, and then my z-axis going to put it over here. These are not going to be nicely right angled either, so you can make, if you want to, you can make like bad matrices as well, where your object is going to be kind of like weirdly skewed and distorted. So what I'm going to do is I'm going to grab, I'm going to get this object here, and I'm going to, rather than asking for its transform, I'm going to give it a transform instead. So I'm going to copy and paste this set of values here up the top, and I'm just going to replace the numbers in it. So okay, for my x-axis, what I'm going to do is I'm going to grab the x, y, and z coordinates for this, and make loads of really, really ugly looking numbers. Okay, for my y, it's going to be this set of 3 things here. And then for my z, it's going to be these things here. Okay, so if we grab this, and hopefully if we hit enter on this line here, if it doesn't give me an error, yay. So now we get a really, really ugly looking object that has kind of horrible rotations, and it's got really, really weird scales on it as well, because I don't know what what distance or length each of these 3 different spheres are from the x, y, and z axis. But you can kind of see, hopefully you can kind of see now that each of these 3 values is kind of just a position, nothing else aside from that. If you want to, when you get into kind of more kind of character rigging and things like that, you can do things to kind of get rid of the scaling out of these values. Like there's a very handy command called normalize, for any of these vectors here. And what it'll do is it'll keep the exact same direction as you have for each of the axes, but it will take the stretch out of it. It'll make the length of each of the vectors only 1, so that there's no scaling left in it anymore. I'm going to see actually, let's see, can I put that in here? 103, so let's see, can we do, it's just called normalize in 3ds Max. I don't know if this is going to work like this. I might have to put in more brackets, but we'll just see. Okay, no, so that's erroring, and I'll do the same thing, but I'm going to put in some brackets. Yay! Okay, cool. So that's worked now. So you can see that the directions are still kind of pointing in the correct ways, the same kind of shitty ways as they were before. But if we have a look at our scale values, are they gone a bit wonky? Yeah, they've actually still gone a bit wonky. So right, never mind me in that sense. But anyway, yeah. So that's a quick run through of how matrices work. Anyway, so the big kind of takeaway from the entire thing is that the last value there is only the position of the object, so that's pretty simple. And then these 3 values here, they're just coordinates. They're nothing else aside from that. So it's not the craziest thing in the world once it's kind of explained like that. I think each of these 3 values here, all it is it's a direction that the x, y, and z axis is pointing at, and if these values happen to be kind of big, then it probably means there's some sort of scale wrapped up in it as well. But again, if you're a technical artist, hopefully this helps you, and it can be useful for some particle bits and pieces as well. So hope that helps. Cheers.